You know, we're surrounded by AI. It's in everything from our social media feeds to huge financial decisions. But have you ever stopped to think about what happens when these super smart systems just quietly fall out of sync with the real world? That's what we're talking about today. AI's invisible threat. I mean, think about it. It really comes down to this question. We update our phones, our computers, our own knowledge all the time. But what about an AI that was trained on yesterday's data, but is still making decisions in today's world? As you're about to see, it's a way bigger and sneakier problem than you might think. Okay, so picture this. An AI that's in charge of who gets a loan. It learned everything it knows during a pretty stable economy. But then, bam, a recession hits. Or maybe people's spending habits just completely change. The AI, though, it's stuck in the past. It keeps using its old rulebook and starts making really bad calls, all without ever raising a single red flag. So this whole problem, this silent failure, it actually has a name. It's called concept drift. That's the technical way of saying the world has changed, the data has changed, and the AI's old playbook is now totally useless, or even worse, dangerous. The rules of the game are different now, but the AI didn't get the memo. So how in the world do you catch a problem you can't see? Well, this is where some really cool new research comes in with a system called XDrift. And you should think of it less like a dumb smoke detector that just shrieks when there's a problem, and more like a really smart watchdog that can tell you exactly who's at the door and what they want. So how does this smart watchdog actually work? It's a really clever two-step deal. First, to avoid crying wolf, it doesn't rely on just one signal. It actually gets a consensus from 4 different methods to confirm there's really a problem. But then, and this is the genius part, it doesn't just bark. It tells you what changed by comparing the AI's internal logic, its decision-making rules, from before and after the drift happened. And this is what's so cool about it, right? It's the move from just detecting to explaining. Most systems out there might tell you, hey, performance dropped at 3 p.m., which, okay, thanks. But XDrift tells you, hey, performance dropped because the AI used to care about customer loyalty, but now it's obsessed with recent purchase history. See the difference? That's something you can actually do something about. But here's where the research uncovered something, well, honestly, kind of wild. A real paradox about the most dangerous kind of change. And it turns out the one we should be most afraid of isn't the big, sudden shock to the system. No, it's something much, much quieter. Get this, the slow, simmering, gradual changes were actually the easiest for the system to spot. But, and here's the paradox, those same slow changes cause the most damage. Why? Well, because it's not a 5-alarm fire. Nobody rushes to fix it. It just keeps making slightly worse decisions day after day, week after week, and all that damage just adds up. This really lays out the paradox perfectly, doesn't it? On one side, you've got amazing detection. We're great at spotting it. The error rate for detection is super low. But on the other side, you have this massive performance hit. It's like we're watching the problem happen in crystal clear slow motion, but it's already done a ton of damage by the time we react. It's the slow burn that gets you. Just let that number sink in for a minute. An 18.3% drop in accuracy. In an AI that's helping diagnose diseases, that's a disaster. In an AI that's trading stocks, we're talking catastrophic. This is the real hidden cost of that slow, gradual drift. Okay, so we know there's a huge problem, but how do we see it? How does XDrift actually pop the hood on the AI's brain and show a person, hey, this is what went wrong? How do you make this invisible threat visible? Okay, check this out. This is how XDrift shows you the problem. You're looking at the AI's brain, basically, visualized as decision trees. The tree on the left is the AI before the drift. The one on the right is after. Now, you don't need to be a data scientist to see that the entire structure has been totally scrambled. The AI is thinking in a completely different way. So what does that crazy-looking chart actually mean? Well, it's pretty simple. Before the drift, the AI's decisions were all about the first 3 pieces of data it looked at. After the drift, who cares about those? They became almost irrelevant. The AI totally rewired itself to focus on a completely different set of information. Features 3, 4, and 5. XDrift makes that massive shift impossible to miss.
So, the big question, does this new method actually work better? Let's look at the scoreboard. This chart shows how long it took for different systems to spot the drift. And remember, lower is better here. You can see the standard methods are pretty slow on the uptake, but look at our method, XDrift. It's way, way faster. And that huge difference you saw in the chart, it boils down to this number, a 47.2% improvement in just how accurately it detects these changes. I mean, that's not just a little better, that's a massive leap forward in keeping an eye on these systems.
All right, let's tie this all together. We have a system that's faster, it's more accurate, but the real breakthrough here isn't just finding the problem, it's understanding it. So why does getting an explanation matter so much? This right here, this is the whole point. Detection is just the smoke alarm going off. It screeches at you that there's a problem. Explanation? That's the firefighter running in and telling you it's a grease fire that started on the stove. One just creates panic. The other gives you the information you need to actually solve the problem. And this is why it's a game changer. These kinds of explanations let us actually trust AI, especially in really critical areas like medicine or finance. It means we can finally stop treating AI like some mysterious black box and start building transparent systems that we can actually understand. It's about putting us back in control. So really, it all comes down to this. As these AI models get more and more powerful and woven into every part of our lives, the real challenge isn't just about making them smarter. It's about making them understandable. How do we make sure that as AI evolves, it remains a tool we can actually work with, that we can look inside of, and ultimately a tool that we can trust?